Welcome to the video presentation of the Phase-1A report submission. This video has been submitted by Team 2D and the problem statement for our team is D. In this video, we have seen through the working of the experiment and also the challenges and the problems faced while doing the experiment. Wiring of function generator circuit. To wire up the function generator circuit, we have used the Type 3 op-amp present in the ASVLK kit. The first op-amp is used as a Smith trigger and the second is used as a non-inverting op-amp. The Smith trigger generates a square pulse which is given to the non-inverting op-amp, which converts this into a triangle wave. Once the wiring of the circuit is complete, the next step is to supply the DC voltage for the circuit to run. We apply plus 10 and minus 10 volts as VREF to the op-amps, since it is the rated voltage of the board. Once the supply voltages are given to the board, the next step is to check its output. Select the auto set button on the DSO so that the output gets scaled down. Next, we check the output with the simulated results on the software. For this purpose, the software used by us was Tina. The output of the simulated result on Tina and the hardware simulation were found to be accurate with an error estimation of 0.5 volts, which is accounted for by the non-ideal conditions. Similarly, the wiring was done up for the multiplier circuit as well. A DC RPS was connected to vary the control voltage of the multiplier. The control voltage was used to vary the frequency of the output waveform. For 0 volts, the frequency of the output waveform was found out to be 0 and a maximum frequency was achieved at 8.6 volts. Challenges faced while doing the experiment. Choosing limits for integration in the proof of time period. MPY634KP multiplier was not available on Tina, so we could not simulate the VCO. The Tina software reported convergence problem for low values of time. The waveform obtained on CRO was distorted, so we had to go for a DSO. Pin configuration of MPY634KP3 is printed wrongly in the legend given in the starter kit. Concepts learned. Changing the values of resistors and capacitors, the amplitude and the frequency of the waves are varied. To convert voltage to frequency, we add a capacitor and discharge at constant current levels. Resistors connected to the positive terminal minimizes the offset by DC biasing currents. Output of Smith trigger controls the time period of the wave. Effects of varied